dH dt, in other words, equals minus beta times HF. This is actually, you could find this in AnyLogic too, as a system dynamics model. We can do an analysis of this, and if H represents hares and F represents foxes, then we have H, the unit of H being hare, unit of F being foxes. To be consistent, H dot dH dt, what units will that have? What units must this have? This, to give you a hint, this is the inflow here. This is the outflow. I know that because of the signs, inflow, outflow. So what units must H, so H is units of hare, what units must H dot have? In other words, dH dt, the rate of change of H. What must its dimensions be? Dimensions must be what? dH dt.
Hairs per time.
Hairs per time. Yeah. And similarly, F dot, foxes per time. That's right. And now we can start to figure out, okay, more. Okay, so what must the unit of alpha be if this plus is going to be consistent, it's going to yield something of hairs per time, and H is measured in hairs, what must alpha be in terms of units? It must be, sorry? Yeah, per time. So some frequency, some sort of chance per unit time, for example. So it so happens it's a birth rate. So chance per unit time of a birth. Beta is a little bit more complex, but it needs to be 1 divided by fox per unit time. So it's actually representing the chance that a hare will meet a fox per unit time. And gamma here is 1 over hare per unit time. Now the interesting thing is, if we wanted to find the frequency of oscillations here, unit of that is 1 over time. It's going to be 1 over time, how frequently it oscillates. How many cycles are there per year, say. And it turns out that this is a particularly skill that people had last century and back. People could look at a model like this and just derive what it must be from dimensional considerations. So among other things, okay, we know the dimension of this has to be unit 1 over time. We know it can't depend directly on beta or H, because it's independent actually of the initial units, and we're not going to be able to have the foxes and hares sort of cancel in them. The dimensions associated with foxes and hares wouldn't be canceled within them. The exponent of time here is -1, and it's actually a symmetry here. So you have sort of alpha and delta in symmetric positions, beta and gamma, and based on that, you can come to the conclusion that the period must depend on the square root of alpha times gamma. Square root, because alpha times gamma would be of dimension 1 over time squared. So to get something 1 over time, you have to take the square root of it. And this is correct. Just from dimensional analysis, from dimensional considerations, and noticing, okay, this is kind of symmetric, so it's got to depend on both alpha and delta. If it depends on one, it has to depend on the other. Can't depend on these guys because foxes and hares wouldn't be able to cancel. And it doesn't depend empirically on the number of hares or foxes. It's got to depend on in this sort of way. And so you could derive it. Similarly, people centuries